Hello students, welcome to Educate. In this video, we will discuss about the preparation of aldehyde and ketone. As I have already informed you that there are some methods by which you can prepare both aldehyde as well as the ketone. In addition to that, there will be a special method for the preparation of aldehyde, and there will be a special method for the preparation of ketone also. So firstly, we will discuss about the special method. There will be the common method for the preparation of aldehyde as well as ketone. That means firstly we will discuss about those method by which we can prepare aldehyde as well as the ketone. So let's see. First one is by oxidation of alcohol. You are already aware when we have discussed about the chemical properties of alcohol. There we have discussed that the 1-degree alcohol gives aldehyde. On oxidation, the 1-degree aldehyde gives alcohol. That is, on oxidation, the 1-degree alcohol give aldehyde and the 2-degree alcohol give ketone. The 3-degree alcohol was resistant for the oxidation, but under vigorous condition that was oxidized to form carboxylic acid. So the chemical properties of alcohol here could be used as a method of preparation of aldehyde. So let's see here. So 1-degree alcohol here, suppose this 1-degree alcohol, this one, when you will oxidize by a mild oxidizing agent, as for example chromium trioxide, then the carbon to which the OH is bonded, that will oxidize to acylic carbon atom. So compound become. So when you have taken 1-degree alcohol, there is formation of aldehyde. When you will take 2-degree alcohol, then what happened? Here OH is bonded to this carbon. OH is bonded to this carbon. So this carbon will convert into acylic carbon. So compound become. So in this way, ketone will form. So one method, by oxidation of primary alcohol, we will get aldehyde, and by the oxidation of 2-degree alcohol, we will get ketone. Okay, next point here. Second one is by dehydrogenation of alcohol. Guys, keep in the mind, it's dehydrogenation, means hydrogen will have to remove, and dehydrogenation is also a type of oxidation, because oxidation is defined as the addition of oxygen or removal of hydrogen, or the addition of any electronegative element, or the removal of any electropositive element. So here same, the 1-degree alcohol, when the 1-degree alcohol will be treated with a copper atom or silver. So what happened? This hydrogen remove, and from here hydrogen will remove. So this oxygen will do double bond formation to this carbon. So compound become. So when the 1-degree alcohol will be dehydrogenated by taking the less copper at here, by taking copper, then the aldehyde will form. And when the 2-degree alcohol will be treated with the copper, then there will be a formation of ketone, because this hydrogen of OH and the hydrogen bonded to the alpha carbon, that will get released, and this oxygen will do double bond formation to this carbon. So compound become. It will be called, okay, name is propanone. So when you oxidize the 1-degree alcohol, then there will be formation of aldehyde. In addition to that, when you will dehydrogenate the 1-degree alcohol, there will be formation of aldehyde. When you will oxidize or dehydrogenate the 2-degree alcohol, there will be formation of ketone. Here oxidizing agent, we will take mild oxidizing agent like CrO3, PCC and so on. PCC is pyridine chlorochromate. Pyridine chlorochromate is a best oxidizing agent because that will oxidize the carbon atom to which the OH will be bonded but will not affect the unsaturated carbon atom. And here the reducing agent we will take as copper. Okay, reducing agent, then sorry, that means dehydrogenating agent we will take copper. Clear? Next point, very important, that is ozonolysis. Ozonolysis means you will have to react with ozone and then after we'll have to dissociate that. So let's see. I'm here making this one short to get here space to write. Ozonolysis. Suppose this compound. Very simple I am taking. That means ethene reacting with ozone. So what happened? Ozone. So there is 3 ozone. So take out the double bond from here. How to predict what will be the molecule? So to predict the product here from the carbon atom between which there is double bond, you remove that double bond. So this carbon is bonded to 2 hydrogen. So here 2 hydrogen will be there. This carbon is also bonded to 2 hydrogen. So here also both the carbon will bond to 1 oxygen. Through 1 oxygen this carbon will be bonded and this through this carbon 1 oxygen will get bonded, and here this one. Someone tell it's temple-like structure. Okay, temple-like structure will form, which is obviously here also. It looks like a temple. Temple of Nagara style, not of Dravidian style. Okay, maybe we would go on that types of temple. So this one here. Then after you react with zinc and acidic water. Then what happens? From here the bond will dissociate, from here the bond will dissociate. So this oxygen will do double bond formation with this carbon and this oxygen will do double bond formation with this carbon. So compound will be here carbon here, one bonded oxygen, and that carbon, this carbon is bonded to 2 hydrogen. So 2 hydrogen here. In the same way, this carbon here, there is also this oxygen will do double bond formation to this carbon. So here, and this carbon is bonded to 2 hydrogen. So this molecule and this molecule is same. So you can write this plus ozonolysis when ozone react with ozone, this form, and then after you can say that 2 molecules of methanol forming here. 2 moles of methanol is forming. So reaction you can also write CH2 double bond CH2, that will be firstly reacted with ozone, there will be formation of ozonide. With 1 oxygen, both the carbon will bond with this carbon, this. Then after when you react with zinc and H3O plus, then what will happen? Bond will dissociate from here, bond dissociate from here. This oxygen will do double bond formation, this oxygen will do double bond formation. So 2 moles of methanol will form. Now let's see another example. This is propanol, propene. Propene react with ozone. So same as everywhere we will do same, everywhere. And because this questions is very important, frequently asked in all the three examination, that is 12th, IIT Main, NEET, in addition to that, IIT Advanced and CUET examination. So that's why I am focusing more on this reaction. In addition to that, this reaction here has some significance also. So questions will ask in the twisted form also in case of IIT Main. So firstly, let's see how to predict the product. Then after, which type of question asked, that's also I shall tell you. So this ozone here, alkene here react with ozone. So take out the double bond from here. So now consider about this carbon. This carbon is bonded to one methyl and one hydrogen. And this carbon is bonded to with two hydrogen. So this carbon here, one methyl and one hydrogen. And this carbon, both sides methyl. With one oxygen, both the carbon will get bonded. With one oxygen, this carbon will get bonded. With one oxygen, this carbon will get bonded. And there will be bonding here. So ozonide will form here. Then after, it will react with zinc and acidic water. So what happened? Bond will dissociate from here and bond will dissociate from here. Bond will dissociate from here, bond will dissociate from here. So this oxygen will do double bond formation to this carbon and this oxygen will do double bond formation with this carbon. So what will happen here? So this carbon is bonded to the oxygen and to this carbon, one side there is methyl and one side is hydrogen. So one side methyl, one side hydrogen, and to this carbon, this oxygen will do double bond formation to this carbon. So here double bond oxygen, and this oxygen, this carbon is bonded with the two hydrogen. So one hydrogen this side, one hydrogen this side. So in this compound here, in the previous reactions, there was formation of methanol. That means only one type of molecule. In this compound, there is formation of ethanol and methanol. One point also keep in your mind that when you remove this oxygen from here and this oxygen from here, and then after do double bond formation between this carbon and this carbon, take out oxygen from here and take out oxygen from here, and then after do double bond formation between these two carbon. So what will the structure? This carbon here will be a methyl and a hydrogen, and this carbon here, that means there is two hydrogen only, this one, and double bond formation between this. Is that not? This compound and this compound is not. So that means here the ozonolysis of alkene is used to predict the position of double bond in the compound. Ozonolysis of alkene could be used to predict the position of double bond in alkene. Okay. So here also ethanol and methanol has been formed. So here both the aldehyde has been formed. In the same way, there may be formation of aldehyde and ketone both from the same alkene if the alkene having the two alkyl part will be bonded to a unsaturated carbon atom. Let's see here. How's this alkene I am taking. IUPAC name you can write very easily. This compound when react with ozone. Again, take out double bond from here. So this carbon is bonded to one ethyl part and one methyl part. So there will be here carbon, one side there will be ethyl and one side there will be methyl. Ethyl and methyl, and to this carbon, one side this carbon is bonded to a methyl and a hydrogen. So this carbon here, one ethyl and one hydrogen. Either you write C2H5 or CH2CH3 in this form, doesn't matter here. And so with one oxygen, both the carbon atom between which there was double bond, that will get bonded. With one oxygen, this carbon will be bonded. With one oxygen, this carbon will be bonded. And there will be bonding between these two oxygen. After that, react with zinc and acidic water. So what will happen? Bond will dissociate from here, bond will dissociate from here. This oxygen will do double bond formation with this carbon, and this oxygen will do double bond formation with this carbon. So this carbon here is double bond. One side there is methyl and another side is hydrogen. And to this carbon here there is double bond and both sides there is hydrogen. So this carbon here, this methyl and ethyl both. This carbon here to this carbon, let's see again. When there will be cleavage here, cleavage will be there. So this oxygen will be bonded to this carbon. So that will be bonded to this carbon. So here carbon, double bond oxygen. One side there is ethyl and another side is methyl. So that will be here. And in this compound here, this oxygen will do double bond formation here. So double bond formation. Then after one side there is ethyl, another side is hydrogen. So here ethyl and hydrogen. So in this compound there is formation of aldehyde as well as ketone. And if you take out this oxygen and this oxygen and do double bond formation here, then what happens? It's here, this carbon here. So between this carbon and this carbon there will be double bond formation. So this carbon atom here, one side there is ethyl and another side is methyl. That is, and this carbon is bonded to this carbon. So now here this carbon here and this carbon is bonded with one ethyl and one methyl. So one ethyl and one hydrogen. So here hydrogen and ethyl. This compound is same as this compound. So it verifies that by the ozonolysis we can predict the position of double bond in alkene. Here, that in this reaction we have prepared the aldehyde and ketone both. In the previous two reactions we have discussed about those reactions by which we can prepare the aldehyde. By the ozonolysis we have prepared the previously two reactions, the last two reactions we have discussed. That in that case, after the ozonolysis there was formation of aldehyde. In this compound here, in the ozonolysis, there will be formation of an aldehyde and a ketone. Now we will discuss about one reactions in which we can prepare the ketone. That means both the molecule will be ketone. Let's see here. So this compound here, now that react with ozone. As I did previously, same we will do right now also. So same here, this carbon here, double bonded. So this carbon here, and that is bonded with one side propyl and one side ethyl. Here also, to this side, one side propyl and one side ethyl. With one oxygen both the carbon will be bonded. With one oxygen this carbon, with another oxygen this carbon, with another carbon this oxygen, with this carbon another oxygen. After that, when that will be treated with zinc and acidic water, same way bond will dissociate from here, bond will dissociate from here. So this oxygen will do double bond formation to this carbon. This oxygen will also do double bond formation with this carbon. So what will happen here? The carbon will be there and there is double bond. One side there is propyl and one side there is ethyl. Here also same compound. Here double bond oxygen, one side propyl and one side ethyl. So two same types of ether be prepared. So we can also write two molecules of this one directly. And when you remove the oxygen from here and oxygen from here and do double bond formation, you will get this compound. So by the ozonolysis, by the ozonolysis, we can prepare both aldehyde and the ketone. In that, one molecule may be aldehyde and another one the ketone. Maybe both the compound will be aldehyde, or maybe both the compound be ketone, depending on the here doubly bonded carbon atom. Okay, that was. Okay, now this reaction here by alkyne. Watch out this one here also carefully. We can prepare only one aldehyde from the alkyne, and that is ethanol. As we just discussed here, that only we can prepare only one aldehyde, that is ethanol. And let's see here, ethanol, methanol. Let's see here. Yes, ethanol. That is, suppose see this compound. So ethyne we have taken. About that, we react with dilute H2SO4. So dilute H2SO4, there will be water, H2SO4 and HgSO4. There will be catalyst. What happen here of the water? There will be H plus and OH minus. So OH minus ion can go to this carbon atom as well as to this carbon atom, because both the carbon atom is containing the same number of hydrogen. So OH minus can bond to any one of that carbon atom. So suppose OH attached to this carbon and hydrogen to this carbon. So compound become here CH2, and triple bond will convert into double bond CHOH. Triple bond converted to double bond, because one hydrogen gone to this side and OH gone to this side. So valency of one satisfied. So that's why triple bond will dissociate into double bond. After that, again react with water. Water or H3O plus, actually H3O plus, H2SO4 here, they can make the water acidic. So water will act, here water will act. So hydrogen, now this carbon is containing only one hydrogen, and this carbon is containing two hydrogen. The carbon atom to which the OH is bonded, that is containing one hydrogen, and the carbon atom, other carbon atom is containing two hydrogen. And you know the Markovnikov's addition rule, that the negative part of reagent bound to that unsaturated carbon atom which contain less number of hydrogen atom. So that's why the OH will bond of this acidic water, the OH will bond to this carbon and the hydrogen will bond to this carbon. So compound become here, this becomes CH3, double bond converted to single bond, and that becomes CH and OH. When the two OH group bonded to the same carbon atom, then compound will be unstable, because shape here is this OH and this OH. Hydrogen of this OH will be close to this oxygen, and hydrogen of this OH will be close to this oxygen. So either this hydrogen will combine to this OH, or this hydrogen combine to that OH. This hydrogen will combine to this OH, or this hydrogen will combine to this OH. That will depend on matter of chance. But it's the fact that water will release when the two OH will be bonded to the same carbon. So that's here. So H2O released, and then after, to maintain its valency of this oxygen and this carbon, there will be double bond formation between this carbon and this oxygen. So then after, between this carbon and this oxygen, there will be double bond formation. There is formation of ethanol. Right now guys, the other reactions will do, but here space I have not, so I will have to erase this this one, what I have written, and you also keep that on the notebook. Okay, here is a space I am writing. No, that is not possible. Okay, so you watch out here, keep this one at your notebook. Okay, watch out that. Firstly, write this one also, because if you will do the reactions like this, you will feel easier. Now let's see next question. Next, so on the place of, if this one, if you take CH3 C triple bond CH, so ethyne you have taken initially. Now propyne I am taking. Then what will happen? So ethyne here same, water will be there, will react with that. So H plus and OH minus ion will be there. Actually, that is taking place in presence of dilute H2SO4 and HgSO4. So now in this carbon is containing 0 number of hydrogen, and this carbon is containing 1 hydrogen. And again, Markovnikov's rule, the negative part of reagent will bond to that unsaturated carbon which will contain less number of hydrogen. So OH minus will bond to this carbon and hydrogen to this carbon. So compound will be here. This one, sorry, this one. Now again, water will react there. That means H plus and OH minus ion is there in presence of H2SO4 and HgSO4, that is happening. So what happened? OH. Now again, this carbon is containing 0 number of hydrogen, because to this carbon atom OH is bonded, not hydrogen is bonded. So this carbon is containing 0 number of hydrogen and this carbon is containing 2 hydrogen. So obviously OH will go to this carbon and hydrogen to this carbon. So that will be same when the 2OH group will be bonded to the same carbon, then that compound will be unstable. So the hydrogen of one OH will combine with another OH and form H2O. So either this hydrogen will combine to this OH or this hydrogen will combine to this OH. So if this hydrogen combine, so there will be formation of H2O. To maintain the valency, when H2O will go, so then valency of oxygen will get destabilized and that of this carbon will also become destabilized. So valency of this carbon and this oxygen will get destabilized. So that will stabilize by the double bond formation between them. So there will be here double bond will form and CH3. So when you have taken ethyne, there was formation of aldehyde. Watch out there, about which we have discussed. But when you take propyne, then there is formation of ketone. Again, to this side or this side, you increase the or decrease the add the chain, then obviously propyne will, then again ketone will form. So by the hydration of alkyne, only one aldehyde can be prepared, that is ethanol, and by the other alkyne there will be formation of ketone only. Okay guys, that was okay. Now let's see, we will discuss about preparation of aldehydes. That means that was the reactions, that was the method by which we have prepared both aldehyde and the ketone. Now we will prepare the aldehyde. That means now we will discuss about those methods by which you could prepare the aldehyde but not the ketone. So let's see here. First one is Rosen-Mundt reduction. Rosen-Mundt reduction. So in Rosen-Mundt reaction, benzoyl chloride, what here it is acylic halide. Acyl halide it is. So the suffix we write here, its method is here. For this one suffix is oil halide. Here chlorine, so that's why chloride. Oil halide there is. Suffix we use oil halide. What happened here? How the reaction is taking place? Now there is that means H2 that can be written as this one. So chlorine will combine with this hydrogen form HCl, and this hydrogen will combine to this carbon. So that means there will be formation of aldehyde. This reaction is called Rosen-Mundt reduction. There is reduction because here hydrogen has been one is that the electronegative element has been removed and the hydrogen has been added. So it's the reduction. So that's why this reaction is called Rosen-Mundt reduction. Okay. So here the reaction catalyst used in Rosen-Mundt reduction is palladized BaSO4. Palladized barium sulfate. Keep in the mind always when you will have to write the name reaction in case of 12th, then you will have to write this reaction, that is palladium BaSO4. In the CUT examination, there is high probability of asking the question that what catalyst is used in the Rosen-Mundt reduction. So palladized BaSO4 uses as catalyst in during Rosen-Mundt reduction. Okay. Now then after is Stephan reaction. About the Stephan reaction, let's see how is that reaction taking place. I am taking this example. It is nitrile. IPAC name how to write? There is 3 carbon atom, so that is propane. Propane. E will retain because the suffix for CN is nitrile. Nitrile, the first letter is of the nitrile. The first letter is consonant and not the vowel. So that's why E will retain. This nitrile react with HCl, that is reacted with HCl and SnCl2. What happened here? This HCl react with SnCl2, so there will be formation of SnCl4 and nascent hydrogen will be provided. The SnCl2 react with HCl, form SnCl4 and nascent hydrogen will be provided. So one nascent hydrogen will bond to this carbon and one nascent hydrogen to this nitrogen. So compound become when there will be double bond between the carbon and nitrogen, the compound is called imine. This one is imine. So its IPAC name will be if there be NH2, that we called amine. Listen here. If there will be carbon nitrogen, there will be a single bond there between NH2, that will be called amine. If there will be double bond between the nitrogen and here, that will be called imine. And if there will be triple bond between carbon and nitrogen, that will be called cyanide. And suffix we use is nitrile. Here same amine, suffix also use amine. Here it's imine, suffix also use imine. And it is here cyanide called cyanide, but suffix uses nitrile. So propanimine, this form. After that, This one form. Then after pass water. Watch out here carefully. So actually we take acidic water, H3O plus. That means a small amount of H plus will be there. So there will be H plus and OH minus ion. So H plus and OH minus ion will be there also. Nitrogen among this nitrogen and carbon, nitrogen is more electronegative, and there is a lone pair of electron at the nitrogen also. So obviously hydrogen will go towards this nitrogen, and the OH minus ion will come to this carbon. So what's the structure will be there? Double bond will convert it to single bond. Again that will react with water. So H plus will go to this nitrogen, that become NH3, and OH will go to this carbon, so that compound become when you have already studied that when there be two OH bonded to the same carbon, compound will be unstable. One hydrogen will combine with another OH, form H2O. So this oxygen will do double bond formation here. So what will be the product? That will be so there is formation of propanol. So here propane nitrile has been used to prepare propanol. Okay, this reaction is called Stephan reaction. During a Stephan reaction, the nitrile will be treated with the mixture of SnCl2 and ConHCl. As a result, there will be a formation of aldehyde and ammonia gas will evolve. During a Stephan reaction, the nitrile or cyanide will be treated with the mixture of ConHCl and SnCl2, and as a result, there will be a formation of aldehyde and the evolution of ammonia gas. Next one here, this reaction is also similar to that of a Stephan reaction. Next reaction, it is similar to that of a Stephan reaction, but reducing agent will be different. So what is here? Suppose this compound. This nitrile, that will be treated with diisobutyl aluminum hydride, it is, or DiBal. What is the structure? So here aluminum is there. As the name indicates, diisobutyl means two isobutyl group will be bonded to the aluminum. So diisobutyl aluminum hydride means the two isobutyl group will be bonded to hydrogen. In the two isobutyl group will be bonded to aluminum in addition to hydrogen. So isobutyl here. This compound is DiBal. This compound is diisobutyl aluminum hydride. Written here. So this compound here, it will be act as also reducing agent. So hydrogen will release from here very frequently. So nascent hydrogen that will provide us by DiBal. Diisobutyl aluminum hydride, the hydrogen gas will provide. So one hydrogen will bond to this carbon, another hydrogen to this nitrogen. So compound become. Again, there will be formation of imine. Then after react with water. That is here. Then after react with water. Acidic water. So what happened? Nitrogen is more electronegative, and there is a lone pair of electron at the nitrogen also. So H plus will get attracted towards this nitrogen, and the OH part of water that will be get bonded to this carbon. So what will you compound here? Again, that will react with water, another water molecule. Same process will repeat here. Again react with, so water means H plus and OH minus ion. So hydrogen when combined to this nitrogen, that become ammonia, NH3, and this OH will bond to this carbon. So there will be two OH group attached to the same carbon, and I have reiterated that when the two OH group will be present to the same carbon, then compound will be unstable. So hydrogen of one OH will combine with another OH and will form the water. So here this hydrogen, this OH will combine to this hydrogen, form H2O, and this oxygen do double bond formation to this carbon. So progressively okay guys, hope this one clear. Now let's see another. By oxidation of methyl benzene, so Ettard reaction there will be. Ettard reaction. Let's see how the reaction is taking place. When methyl group bonded to the benzene, that is called toluene. When the methyl group will be bonded to the benzene, that is called toluene. That will react with chromyl chloride. The structure is like that. Here, due to the hyperconjugation, hydrogen releases from here very easily, so that will bond to any one oxygen atom. So that become OH, this oxygen become OH, and this oxygen will get bonded to this carbon. So compound become this one. Again, and this takes place in presence of CH2, carbon disulfide. Again, the another CrO2, Cl2 will react with that. As taking place like this, same, one oxygen will get bonded to this carbon and another one oxygen will convert it to OH. So compound become this voltage. Then after pass water, so when you will pass water, so whole of this one will release. So 2 OH will bond to this carbon. So of this benzene, carbon bonded to the benzene, that will be also bonded to 2 OH. Same, there is 2 OH present to the same compound. Say the 2 OH group bonded to the same carbon, that will release in the form of H2O. So there will be, so benzaldehyde will form. So during it, by the Ettard reaction, we prepare the benzaldehyde. By the Ettard reaction, we prepare benzaldehyde by reacting the toluene with chromyl chloride in presence of CS2, carbon disulfide. Same, then after this reaction with chromic anhydride. Toluene that react with chromium trioxide and acetic anhydride. Acetic anhydride will be like that. This one. So hydrogen of this methyl, one hydrogen of this methyl, one hydrogen of this methyl will bond to this oxygen. So that's related, that form acetic acid, and this C double bond O, that will here, this hydrogen will form, and this oxygen from here, this oxygen will get bound to this side, not there. This will bond to this carbon. Bond will dissociate from here. So this oxygen that will be bonded to this carbon. So bonding will be I have written like this one, OCOCH3, that is here. This oxygen singly bonded to the carbon, this oxygen doubly bonded to this carbon and this CH3. And like that, again this process will repeat. So finally there will be a formation of, this will repeat. So then after one hydrogen, same, this compound will be there, this compound. So same, other one will be also bonded. Then after pass water. So this whole process that will get released from there. That will convert it to acetic acid. And the OH will bond to this 2H group, will bond to this carbon. Now, since the 2OH group is bonded to the same carbon, that's why the 2OH group is bonded to the same carbon. That's why that will release as water. So structure will be here. That was this reaction. Okay. Now let's see the other reactions. That is side chain chlorination followed by hydrolysis. Same here, toluene. This one, toluene here. That reacts with chlorine in presence of light. Keep this one seriously. That in presence of light, when halogenation will be done, then halogen will bond to sides this methyl part. And if there be any Lewis acid, like anhydrous AlCl3 or FeCl3 or FeCl2, then the chlorine will bond either to the ortho position or at para position. Keep in the mind that when halogenation of toluene will be done in presence of light, then the chlorine will bond to the methyl part. While when the halogenation of toluene will be done in presence of any Lewis acid, then the halogen will bond either to the ortho position or at para position. So what happened here? One chlorine will bond to one hydrogen. It can be written as like this. So one chlorine will bond to one hydrogen. So this one bonded to this hydrogen. So this chlorine will bond to this carbon. In the same way, another chlorine you react, then again one hydrogen will bond to with this one chlorine from HCl, and another chlorine will bond there. Now pass water. So directly I am showing two water. So this hydrogen will combine with one chlorine form HCl. So this chlorine will bond to this hydrogen form HCl, and this chlorine will bond to this hydrogen form HCl. So the 2OH group will bond to this carbon. So here now the 2OH group is present to the same carbon. So compound will be unstable. So one hydrogen will combine with one OH form H2O. This oxygen will do double bond formation to this carbon. In this way, there is formation of aldehyde. Now let's here by Ketone-Koch reaction. Next portion. Let's see by Ketone-Koch reaction. This reaction. What happened in Ketone-Koch reactions? Here, benzene is that react with carbon monoxide. The structure is like that. That react with HCl. So what happened here? In this case, carbon monoxide combined with HCl, then chlorine will get bonded to this carbon and this hydrogen also. So to maintain that, so structure will be like that. That is the structure. So that this react to form like this structure will form. Now the hydrogen attached to the carbon of benzene that will combine with the hydrogen the hydrogen of the benzene that will combine with chlorine and form HCl. So this acylic carbon atom will bond to this carbon. So structure will be so in this way Ketone-Koch that means benzaldehyde will form. So that was the special method for the preparation of aldehyde, and in the next class we will discuss about the special method for the preparation of ketone. It's all for this class. Thank you, Team Educate.